open house, and now we'll be doing the live session. And with me, I have 4 panelists. Can you introduce yourself?
Hi, my name is Ryan, and I'm studying chemical engineering, and I'm in my final year.
Hi, my name is Marcus. I'm in chemical engineering as well, and also in my final year.
And I'm Yerim, year 2 in biomedical engineering.
Hi, I'm Alex. I'm a final year e-scholars student.
Hi everybody, my name is Len Rui Yong. I am the immediate past vice dean for the undergraduate education. So I'm here sitting in the live chat panel to try to address if you have any admission criteria related questions.
Right, thank you. So for any viewers out there, you can type in any of your questions down in the comments below, and we'll be addressing them one by one. So you can keep your questions flowing. Okay, so before any questions come in, we can discuss about the school experience and the curriculum over here. So Ryan, can you share with us how your experience in NUS was like?
Okay, hi. So I'm actually in the polytechnic track. So it's a 3-year degree, and so far I find that it's been quite great. Within these short 3 years, I have went on like a summer exchange as well as a summer internship. Yep, so I would say that it's really quite fulfilling, and I managed to make a lot of friends and gain a lot of experiences throughout these few years.
I think across these 4 years here, I think the NUS curriculum actually helped us to prepare us to be very relevant for employment after graduation. So actually there's a lot of modules that require like software training, Excel skills, which are very, very relevant to what we're going to do in our attachments and also in our jobs afterwards, after graduation. So for me, I think that I prefer like the innovation path. I like going to think out of the box. So actually for me, I went on the NUC Singapore program. So I actually worked at a startup company to help with the marketing efforts, and also had the chance to go over to China to work with the counterpart company over there.
Yep. So for myself, I think in NUS you have that kind of unmatched flexibility. You have the chance to try out many different things, from NOC to exchange. So for myself, for instance, I went on a year exchange to Imperial College, and it was a very amazing experience. I had the chance to learn from top academics from around the world. And I think in NUS, there's also that kind of focus on technical excellence. So for instance, I did a undergraduate research program with some professors. So you get that kind of technical exposure in NUS, and it's that kind of unmatched flexibility which we offer.
So how was your experience teaching as a teaching staff in NUS engineering?
Oh, actually, NUS is one of the local universities actually very much emphasized in teachings and educations. Although I think if you look at NUS rankings, one of the major components is actually the excellent research that our faculty members are doing, and of course, I'm no doubt that all our professors are doing very excellent research. But the universities has been emphasizing a lot in education, and we have been receiving a lot of resources from universities to actually boost up our pedagogy, the way that we educate students. And you will see that we also use a lot of technologies in our teachings nowadays as well. And if you ask some of your friends that are right now currently studying in NUS, you will know that based on the current state of this coronavirus environment in Singapore, we actually have activated a lot of e-learning. So many of our students, they don't need to actually come to the class, and we have simulcast that we can talk to individual students over the web individually and together with the other classmates. So those are fairly good infrastructures that NUS has provided us to basically do the remote learnings, which I think a lot of our students find it very interesting and enlightening experience as well.
Right, thank you. I think a lot of students who want to come into NUS engineering are curious what they will do after they graduate. So can you share with us about some of the career prospects or what you plan to do after you graduate?
So I think it really depends on your major itself. So for instance, in chemical engineering, it's very diverse. People go into oil and gas, people go into finance, banking, really all the different industries. So if you think about engineering, at the end of the day, it's all about learning that kind of, you learn about how to solve problems. So you become very well trained. You have a very good logical kind of mindset and infrastructure in your mind itself. So like for instance, I'm planning to start my career out as an investment professional. And for instance, Marcus as well, he's going into the semicon industry, and Ryan is going to oil and gas company itself. So really within engineering, you have that whole diversity. You're not limited by just being in an engineering company. You have that experience to try out many, many different things. And that's the great thing about NUS engineering as well, because it really prepares you. It lets you explore the different things which might interest you, be it like coding. So some of our engineers end up being software engineers in Google, in the big tech companies. Some end up as consultants. So the career pathway and the career prospects for engineers is really, really bright. And it's something which I believe NUS engineering really trains us very well for.
Right, as mentioned, there are some pathways of career prospects such as the investment or going into professional pathway. But actually, if you go into engineering, you can also go through an entrepreneurship pathway, or you can also choose to go to a research pathway. So we actually have 3 pathways in our NUS engineering. Could you share a little bit more about that?
Yes, so in NUS engineering, besides the professional pathway that we just heard, we also have the innovation and design pathway. So this is a way to actually get students with different disciplines, different engineering disciplines to work on a real life problem. And so students in this program, they will actually join hands to hands to look at a real life problem, and then over a long period of time rather than one semester, they will have 2 to 3 semesters to work on a specific real life problem and then try to propose solutions. And as a matter of fact, some of the former students, they really like their projects, and at the end when they graduate, they actually establish a startup based on the project that they have with the innovation and design pathway. The research pathway is for those who are very interested in establishing research careers, which require a lot of depth on understanding the new technologies. And so in our program, we also train students who have the most updated technologies. And in these days, engineers cannot do without the use of computational skills. So we have already integrates quite a number of computational elements in all the engineering programs, so that when our students go out, when they work with either very deep projects, research project related, as well as in a company, they will have very good computational skills to handle that. Our research, as I mentioned earlier, NUS is quite well known for our research, and our research has also made a lot of impact in the local society as well as overseas communities. And so with students who have the aptitude to do research, NUS is actually a very good environment. And we also partner with many of the top universities in the US, in the Europe, for research exchange, as well as for PhD studies. So those are I think the points that I think allow our students to explore their research interests if they join NUS engineering.
Maybe to build on Prof. Narin's point on the topic of innovation. So actually engineering actually gives you the technical skills to help solve a real life problem in society. So for instance, one of my friends actually created a wheelchair with a shelter over it that is actually foldable. So this actually solves the problem of people in wheelchairs actually undergoing through a lot of harsh weather elements. Should it rain, then it's very inaccessible for them. So the skills that they learn throughout this entire process of developing the product, prototyping, And these are all, like, for example, market validation skills that actually is very applicable in society, very applicable after graduation. So these are the skills, these are all the soft skills that we can actually be able to learn in NUS engineering. And this is one of the reasons why NUS engineering is actually very flexible and also very relevant as well.
We have a question about the subject specialization that will occur within our courses. So when can people apply for the specializations, and what are the requirements needed for them to specialize into certain areas within their courses? Could anyone share about that?
Okay. Let me take this question because this is quite related to the admissions. For those who are interested in join NUS engineering and then apply one of the specialization, they can actually do so when they fill out your admissions application form. So we have two tracks or two ways to actually get into the specialization. One is during the admission you can apply as mentioned. So for those who are interested, please feel free and go ahead and then sign up for any specialization that you're interested. In addition, if you're not sure whether the specific specialization is for you, you can always come in and join us first. So during the first 2 years especially, you can actually discuss with your professors and then decide whether those specializations is of your interest. You can even do a project with some of the prof in that specialized area. And if you're interested in the specializations, within the first year, you can actually submit your request to join the specialization and then basically then study and fulfill the specializations.
So to summarize, do not be worried too much about specialization, as you will have more chances later on to choose your specialization, or you can indicate it when you're applying for your required courses. So another question we have received is that a lot of JC students who have taken biology feel that they might be disadvantaged because engineering is heavily focused on physics. So what are your thoughts about that? Do you think it will be a big problem to them?
Maybe I could just share from my friend's point of view. So agreed that actually there's a lot of physics content in engineering, definitely. But however, actually NUS prepares us through the bridging courses. So for my friends who actually went through the bridging courses, they completed 2 modules in physics. And after completing it, actually they feel that it's not a very big hurdle, not a very big step to jump and to match the gap between if you take physics in A-levels. So I think for those who are actually very worried about not taking physics in JC, don't worry. I think NUS prepares you adequately to cover over this physics gap that you have. Yeah.
So there are plenty of physics bridging modules to help you prepare, even though you took biology in JC. So don't worry about that. Okay, so most of you are from chemical engineering. So Alex has shared that his career prospect is other than what people mainly think the chemical engineering is about, so oil and refinery field. So what are your thoughts about having different diverse fields? We have mentioned it earlier.
Sure. Yeah. So I think in terms of like chemical engineering, you're not just bounded by oil and refinery. So there's a lot of other pathways available. So research, for instance, is one kind of pathway which some students do take. Other pathways also include things like food technology, maybe in microelectronics, and there's a lot of different industries. And even in terms of like optimization, so being a software engineer. And not only that, there are a lot of other kind of pathways like a consultant and maybe as investment professional as well. So there's many different kind of paths available to engineers itself. So we are not limited in the sense that if you are a biomed student, you only end up in a biomed company. You actually have a lot of different career prospects available to you, and you shouldn't be limited to that kind of narrow scope, because NUS engineering really prepares you. So like for instance, they've been rolling out modules which now includes things like machine learning and coding in Python. So these are the kind of some of the initiatives where NUS engineering is really prepared to make you future ready in that sense.
Just to build up a bit on what Alex said, so you ask what is chemical engineering. So many people have the misconception that chemical engineering is about chemistry, but in actual fact, what we actually do is we manage processes and we design processes in the different industries. For example, in oil and gas industry, we we're actually conducting distillation to produce many different petroleum products, and in pharmaceuticals we produce different medications. So what we actually do is we are actually controlling and also, in a sense, designing different processes in order for these products to be produced safely and in the most efficient manner. Yep.
Just to add on to the student has been mentioning, which is fairly complete pictures, but again, I think engineering itself, we in NUS engineering, we train our students to actually have this analytical thinking, critical thinking, as well as problem-solving skill. So if you look at the graduate survey, most of our graduates, I would say half of them, they actually stays in the disciplines or the professions that is directly linked to their disciplines that they study. Half of them, they actually branch out and do many other things. I think investment banking, I should not mention more, but we do have students go to investment banking. As a matter of fact, I was talking to a few students who are interested in investment banking, and then try to connect them to a business school professor so that they can get an internship in investment banks. But why you should ask the question, so why those professions that seemingly has nothing to do with engineering actually recruit engineers when they graduate, and they don't just recruit one or two, they recruit a lot. And the reason is really the training that behind that is the way that we train our students to be able to have holistic pictures of a problem when they just present to them, and then split the problem into pieces so that it's manageable, and then they will be able to actually find solutions to problems with different facets. So those are the skills that I think engineering training or we present to students. And on top of that, the Innovation and Design program actually add a different dimension. So besides all these hardcore engineering analytical skills trainings, the Innovations and Design program allow you to link directly to the industry, to the clients that present you the problem. And from there, you can have a direct interaction to understand what is the real life problem. So that actually help you to bring out what you learn in the textbook and then come up with a way to solve the problems that is having societal and commercial values, rather than just looking into, after you finish some concept, go to the back of the textbook to try to solve some imaginary problem. Those are simple problems that can have a gap with the real life situation, but here in NUS we have a lot of those training will actually help you to bridge the gap. So when you graduate from us, then you are in a more what we call future ready positions to actually get into the career that you desire, either professionals, engineers, or do your startup, or if you want, do your research and advance your research interests. Yep.
Right, thank you. So I feel that the engineering degree will prepare you for whatever field you want to choose in the future, as it has some of the things that is applicable to all fields. Right? Okay. So another question we have received is, for physics and engineering, they seem to be overlapping in many areas, and engineering requires physics. So how are they similar, and how are they so different that sets engineering apart from physics? Can anyone share?
Maybe from my preliminary understanding about engineering and physics, fundamentally the theories, the calculations, they are more actually driven from physics. All these experimental, all these calculations in theory. But however, for engineering, it's more of an application of physics, how the theories in physics, how can you apply to real life situations. So we may be learning differentiation, integrals in physics, but then in engineering aspects, how are you going to use that differentiation, that integrals to apply to maybe building a pipe, to estimating the fluid flow in the pipe, and all these are actually helping you to create a real life product. And I think that's one of the main differences between engineering and physics, the real-life application of engineering itself.
So I also agree with you. I feel that engineering is more about doing and applying to real life, while science and physics are more about learning new things about the field. Right? Okay, so next, Prof, do you know anything more about material science engineering? It might be a new concept to many of the JC students. And what are the career prospects that you can foresee if you join material science engineering?
Actually, material science and engineering is actually quite a modern engineering disciplines. I think it evolved from the conventional civil, mechanical, electrical, and mechanical engineering. But if you think about materials, we actually live in a world surrounded by materials. You look at your handphone, okay? The glass on your handphone is a product based on material science. And you look at the way that we drive the car. So now cars have become more green, and one of the reasons we can make it more green is the materials that we use to manufacture the cars become lighter, and yet still have that strong properties that can take the impact in the case of an accident. So the safety is not compromised, but at the same time we make it lighter. And another example you see is the Dreamliner. And the Dreamliner, the Boeing 787, is another product of engineering, and including materials engineering. Again, they come up with a way to use a new material instead of the traditional steel body, so that we make the airplane body much lighter, and so they save fuels. So all these are actually part of the achievements of the material science and engineering. Now, in the more local context, most of the local material science and engineering related industry typically, well, I would say there's a major shares are actually towards the semicon. So there's a number of semicon related companies, they actually hire materials engineers because they are needed for them to do some of the material design, and which is a main semiconductor industry's requirements. And besides, like for example, you have engines company like Rolls-Royce, they also look for material science because, again, in the development of a new engine, you need certain new materials requirements, and so that's where material science graduates actually work in the industry. And on top of it, because a lot of material science are fairly advanced in terms of their understanding and their application, so quite a number of students who are interested in material science, they actually also pursue graduate studies. For myself, I'm actually, my undergrad is trained as a chemical engineer, just by coincidence. There's a lot of chemical engineering here. But during my PhD, I actually morphed into material science because that is the frontiers of many of the scientific problems, that when you try to leap through to a new applications, right now a lot of questions lies on material science. One more example, again, you cannot live without it, is your battery. Your battery, the most updated version that we use is this lithium ions. This is not very new anymore, but it is an invention from material science. And so with increasing demands for all these mobile devices, a lot of material science are also looking on new batteries, so they can have more joules, more capacity to power your 5G or 6G power requirements. So those are actually very innovative areas. So if you are interested in material science and engineering, do consider, and you can talk to our departments of material science and engineering more to try to get more information on it.
Right. Thank you. Alright, so right now we have our dean here. So we'd like to invite him in to join us in answering the questions.
Okay.
Hello, welcome.
Hi.
Okay,
Okay,
could
let's
you
go.
introduce ourselves for the viewers?
Okay.
Introduce yourself.
My name is Aaron. I'm the Dean of Engineering. So I became Dean just last year. So yeah, that's me. Okay. Oh yeah, and I'm trained as an electrical engineer. So if you want to know about electrical engineering, just just bring on the questions.
Alright, reminder to our viewers, you can ask the questions in the Facebook or Instagram comments and we'll be answering them one by one. Okay, so for Dean, we have a question for you. What kind of qualities do you think NUS engineering can nurture in our graduates?
Okay, so qualities, there are actually many qualities, but the few important thing is oh, yeah, sorry. Okay, so there are several qualities that we're looking for, but definitely resourcefulness, problem solving are the most important part about engineering graduates that we're looking for. And the reason for that is because most of the grand challenges that you're going to see when you graduate are the ones where the problems are pretty big and they involve many different fields. So it's important that to bring people together, and bringing people together also means having the team come up with new ideas to solve problems. That's where resourcefulness comes in. Ability to work as a team, very important. So those are the basic soft skills that we are looking for now. Obviously, engineering basically gives you a lot of basics and fundamentals in problem solving. So these are the hard skills in terms of math, science, physics, engineering problems. So those are your sort of a bread and butter that you need to have. And so bread and butter plus the soft skills, you'll be golden.
Right, thank you.
Yeah.
So you mentioned you're from electrical engineering, you're trained in that. So can you tell us whether the electrical and electronic engineering will include artificial intelligence, which is a very hot topic in our society right now?
Okay. Yes, actually, artificial intelligence, always people think that is about computers. Okay, it's actually not necessary. So actually, electrical and electronic engineering does include artificial intelligence. Just for instance, most of the AI or machine learning today is done on something called a GPU processor. Okay, so GPU processors are microchips that are built by electrical and electronic engineers. So new computing architecture that goes beyond today's AI will actually be enabled by hardware. So hardware and software needs to work together. So definitely, we are actually offering a core program on machine learning that will basically give students a broad overview of what machine learning is, equip you with the necessary skills so that you'll be competitive. Doesn't matter you eventually graduate to go into hardcore hardware-based machine learning, artificial intelligence, or into data analytics. You have the necessary skills to perform well and compete.
Right, thank you. Next, we have a question for the students. So, beyond academics, which engineering, they feel that we are always about studying and academics, but it's actually not true. We have other things that we do in school. Could you share about what you have done in school that may be different from academics?
So for myself, besides academics, I do quite a bit of rock climbing, so that's on my own externally. But besides that, I'm also the president of the Engineering Scholars Student Committee. So for us, we look out for our engineering scholars. We organize events, and we are constantly, creating connections with the alumni, and ensuring that there's this consistent kind of bridge between the alumni and the current students. So that kind of gives you and ensures that amongst engineers itself, we have an understanding of what are the future career prospects, and what are some of the things which we should look out for when it comes to understanding your major better. And I think Ryan would also like to share some of the things he's done.
Yeah. So in NUS, I feel that there's a lot of room for self-development. So I was very actively involved in CCAs during my first and second year. Back in my first and second year, I was in the Chemical Engineering Student Society. So what we do is actually we plan many events for our chemical engineering students. Things like welfare events, as well as industry talks and industry visits. So all this actually helps the student get to know more about what they can do in the future. And at the same time, we're also caring for their welfare. So because in university, times can be tough, workload, like for example, academic workload. So we are always there to try to bring some support to the students. And at the same time, when you say, right, you actually get to interact with a lot of people, get to know more about different working styles, and this actually helps build on your soft skills and communication skills, which is very important to the workforce in the future.
Okay, I agree with Brian. And disregarding all your career respect and all those like things that will help you for your future, just for fun, you can join a lot of different CCAs. You definitely have time to join. You can, for me personally, I've done taekwondo for the first time in my life. So it's like trying new things. University is really about trying new things, and you definitely have enough time even if you join engineering. And I've also joined overseas CIP, so I've had a chance to go to Cambodia and interact with children there and teach them new stuff. So it was like a new experience for me, so it was really fun. And this is apart from academics, but it will also help me in my undergraduate life. Alright, so another question we have is about the electrical engineering again. So they want to know about the career prospects and also whether they can specialize in robotics if they join the electrical engineering.
Okay, I guess I take that question. So, EE is a very, very broad area. Actually, it's not just one. So it basically spans anything from control systems, wireless systems, digital systems. Many different areas are actually covered within. So anything that you effectively can control or pass electricity through, that's basically EE to some extent. Now, your eligibility to do robotics, for sure. I think that if you're interested, I think it's important. Now, robotics is actually a multidisciplinary field. So it involves both basically electrical engineering control systems, computing systems, plus mechanical systems. And I think the job prospects is fantastic. You know why? Because you heard of this thing called Industry 4.0. So this is a lot about automation, about smart factories, smart manufacturing. Robotics will factor a big part into that arena. So I think it's definitely I think it's a very attractive field to get in. And again, as I mentioned previously, and as I introduced myself, I think one of the qualities we look for students is resourcefulness, able to work in a team, and that implies that you're open to multi-disciplines. So don't be afraid to cross boundaries. Okay.
Alright, thank you. The next question is again for the students. If you think of engineering, you might picture us like just on our books in lectures, listening to lecturers talk. So how true do you think this statement is? How often do you stay in tutorials and lectures, and how often do you stay in labs or other group works? So
let me just address it in the sense that NUS engineering gives you the opportunity to go on student exchange programs, for instance. So like for myself, I spent a year abroad in Imperial. So in that sense, I had a slightly different kind of experience. And in Imperial itself, there's a pilot plant. So I had the chance to actually go down to kind of like a mini-scale plant itself. But even within NUS itself, you're not just stuck with lectures and tutorials. So let me give you some examples. Like I did a UROC project with a professor. So in that, it's basically an undergraduate research project. So under it, we were able to kind of publish a paper together. And it was about materials basically and membranes. So in that sense, there's opportunities besides mandatory lab modules which students have to take. So typically it's about 2 modules of lab work which you will do. And you also spend your time, if you want to, you can actually do more lab work by yourself. Like I initiated the UROPS project under my own initiative. And some students as well, they do this thing called the final year project for some majors, where you actually get a chance to embark on a research question which kind of interests you. So some of my friends have done the research questions based on maybe optimization of certain chemical processes. Some of them have done it on membranes. So there's really that whole diversity when it comes to NUS research itself. So you're not just stuck in lectures and tutorials. There's a lot of hands-on learning. So for instance, in right now we actually have the foundational modules where it's very strong and very heavy emphasis on hands-on learning. So we have like back-to-back, so you spend like 1 lecture and the next, and within the week itself, you also have a chance to try out what you learn in lecture in lab sessions. So we have that kind of hands-on experience and exposure, which it's very hard to get in many other different universities.
I think for this question, it depends highly on which year you are and which course you are in as well. So I think that lectures and tutorials set the foundations for your learning. So in year one, you will be expecting a bit more lectures and tutorials than upper years, where you'll be focusing more on your research projects. But also in lower years, you have fairly large amount of lab sessions where you can apply your learning and see how it applies in real life as well. So there are also questions about masters or PhD, those students who want to go on further their academic learning after they have finished their undergraduates. So are these specializations only for those type of students, or are students who only want to stop at bachelor's applicable to do specializations?
Okay. Yes, okay. Yes, there are two things. One, there is a difference between specialization when you are undergraduate, right? And then there's specialization. Okay, I've been prompted to smile. Thank you. Yes, there are two levels of specialization. So we are building more specialization at the undergraduate level. So these are undergraduate programs that actually prepares you for certain new emerging industry, okay? So that you are basically relevant for the future. Now, when you want to do masters and PhD, it's different. So in bachelor's, we train you, we give you the necessary basic skills, and in masters and PhD, we train you to be experts. So that is different. And there, the specialization normally comes naturally because you'll be solving very specific problems, much deeper. And here we're preparing you to be an expert in the field. So for instance, once you get your PhD, always people address you as a doctor or something. And that's the reason, because now you're seen as an expert in that field. Hope that clarifies.
Right, thank you. I think one question that most GC students have right now is about the admission. So could you tell us a bit more about admissions? What are the criteria you look out for the new students?
Actually, NUS engineering has a whole wide spectrum of disciplines. And so we are looking for students who actually want to make a difference when they graduate, to make an impact to the society, as well as in their careers. And we try to, as discussed earlier, we try to train students to have this problem-solving skill, analytical thinking, and be resourceful. So all this, I would now say, is a concept of knowledge. To me, all this, at the end of the day, is tools in your toolbox. Okay, so we basically train students to have a good toolbox, and then they can flourish when they go out and develop their careers. So in terms of the type of student we want to admit, of course we want to admit the student who have a passion in engineering and want to make an impact in the society. And over the years, I guess back to the JC and the poly students, we're of course looking at your science subjects, as mentioned earlier, your physics. Even if you have a bridging module, but you have physics, then of course we look at your physics grade. If you don't have the physics, then we'll look at other of your science subjects like math, chemistry, etc., etc. And for those that set the foundations on whether you have the basic knowledge to actually join engineering. But besides, we look at those students who have those strong foundations. We also admit students who have special quality, like for example, if some of the students in previous years show strong entrepreneurial spirits, that they have done. I have students already done startup before even they join university. So those are special quality that we believe, again, even the science subjects grade may not be that strong, but with for example, as I said, the entrepreneurial element, that actually speaks by itself as to what the student aspire to be when they graduate. And so those are special considerations that we will actually admit students based on those special qualities. So if you do have those special qualities, don't be shy and make sure that you include those in your application when you do your application, so that we know those information. So we'll take those into consideration when you review your application case.
Right, thank you. So I think the next question is relating to, again, science versus engineering. It's a very common question, one that I had as well. So for me, it was biomedical science or biomedical engineering. And there's also computer science and computer engineering. So there are a lot of students who don't know what is the difference or which one should they choose, which one is more fit for them. Perhaps you can share with us about, Orion, you can share with us about why you chose chemical engineering instead of chemistry.
Back in Polytechnic, I studied chemical engineering as well. So the difference between chemistry and chemical engineering is that chemistry is about lab scale experiments. So possibly you want to create a product. So when you are actually creating at small scale, you are doing it in the lab, right? Whereas for chemical engineering, we are bringing it upscale. So we actually have to go through very heavy equipment, and as well it's very, how to put it, you're actually upscaling it by a lot. So when it comes to that, you have to consider many things, all the operating parameters, and how to actually keep all these operating parameters in control in the desirable reaction conditions so as to produce your products. So I think that's what's the difference between chemistry and chemical engineering.
Sorry.
So I think besides that, if you talk about like science and engineering at the end of the day is about being able to apply scientific skills, scientific knowledge onto problems itself. Science addresses very specific problems, for instance, and engineering, on the other hand, what you're doing is you're solving a problem using using some mathematical skills, mathematical knowledge which you have. So that kind of broadness means that you can apply it in many different fields. You're not just limited into the field of solving science problems. You can apply it maybe in the field of solving financial problems. What's the best way for a company to optimize profit? Or maybe like a shipping company wants to deliver goods. What's the best delivery schedule which they can do? So these are the kind of problems which you get to solve in engineering. It goes beyond just solving very specific skills, specific questions. So you get to try it and apply your knowledge to many different things. Yep.
And so this debate between science and engineering has gone on a long time. I think science, to some extent, very well, because since your primary school days to your secondary school days, you have been exposed to what science is, doing experiment, understanding the theoretical background. But I think engineering is actually quite unique. It's actually like what they said, which is there is an angle of application. It's about basically looking at it from a systems point of view, bigger picture. And that's why it's actually preparing you to tackle problems to solve at the large level. Now, the question regarding difference between computer science and computer engineering, I think that discussion and that questions pop up very often. I mean, just to dwell into that particular example is, for instance, computer science studies the software layer of the system. So how the applications are written, how you use the applications, how do you develop new applications. Now what computer engineers do is that they do more than just that software layer. They go down into the operating system, beyond the operating system, the compiler, to the hardware that enables the software. So you can see that this whole thing actually wraps into a system. Just like chemical engineering or that is to look at the full systems when you actually implement it. And so that's why typically an engineering program gives you a much broader view of the problem. Okay, you can definitely pick up the science part, which you have already done since your primary and secondary school, and then now go forward. If you want to look deeper into the application, you want to make something that you can build useful in terms of hardware, even hardware plus software. I think engineering is for you. Okay.
Thank you. And for students who are applying for their universities, they will compare between universities and different programs offered by different universities. So how would you compare NUS engineering program with the SUTD engineering program?
Okay. So it's going to be hard always to do a one-to-one comparison. There's a qualitative difference definitely. SUTD definitely emphasize on design, but that doesn't mean that NUS engineering do not offer programs that focus on design. In fact, we have a program called Innovation Design Program, which actually basically culture your maker's spirit and maker's skill. So that is project-based, it's experiential, meaning what? Instead of spending all your time in lectures, you're actually in a team building something. And we already have many success stories that we probably can go to when IDP comes and talk about the program. And I think this is definitely something that you definitely should ask when I think they go live according to the prompt board to be at 2:30, right? Yeah. And I think this is a good opportunity to find out more about the program. But the neat thing is this. This is where future engineering education is going to head to. That is, we will be training engineers that work with their hands, with their heads, and work together in teams, rather than just book learning. And I think this is something that we emphasize. So, that's one unique aspect of our engineering program to be. All right.
Right. So for the question for the students now. So, sorry. So have you been engaged in any hall or residential experiences? When they come into engineering, they might also want some hall life or residential life. Have you been involved in any of those?
Yeah, I'll take the question. So during my first 2 years of uni, I stayed at the King's Edward 7 Hall. So it's actually a hall stay right beside PGP near NUH. Just a bit far from engine, I know. Because most of the engineering freshmen would normally like to stay nearer to engineering, which is Raffles Hall. So a bit about my hall experience is that I feel that it's a very great place for you to discover and learn new things. So for hall, it's actually a small setting, so you're actually able to join many of the different CCAs and committees that they provide. So I myself joined like around 5 CCAs. They have a good mix of sports and committee. So through there, you get to also get to know more about students from other faculties, like what they study and how their course is very relevant to the industries in the future. So I think it's a very good experience to have and a great opportunity for you to network and make new friends, know more about different people and their lives. Yep.
Yep. So for myself, I'm actually still staying in a residential college 4. So residential college 4 basically is part of the UTown college program, UTCP for short. So basically the idea of residential college is that you get to take electives over there. So you get to take special modules which are catered towards a certain theme. So for instance, in RC4, we are gearing towards the theme of systems thinking, so which is very relevant in engineering because you are thinking about things in a big picture, macroscopic point of view. So systems thinking kind of goes about solving very complex problems which might bog down the system and trying to find ways to go about optimizing certain processes, be it maybe implementing policy changes. So these are the kind of questions which we address in RC4. So residential college is basically a unique system which NUS offers, where you actually have the chance to take on special modules which answers certain questions or which caters towards a certain theme. And so that's the kind of residential experience I had as well. And I found that RC4 actually complemented my education in NUS engineering very well, the whole systems thinking focus.
So not just engineering curriculum itself, you can supplement it with your RC experiences or hall experiences. Just for the viewers, the nearest hall to engineering will be Raffles Hall. But that is not the only factor that people think about when they choose halls. So, but just an information. Okay, so one of the things we cover in engineering curriculum is going on an industrial attachment or internships. So it is a crucial part of our learning here, but do all engineering students, are they all required to go on the internship program?
I think engineering, NUS engineering thinks that internship and work experience is an integral part of the whole engineering training. So I'll probably look into the two groups of students. So for the students who come from the A-level background, most of you may not have exposed to any internships and working experience that related to your training. So for internship, it is compulsory for A-level students. For poly students, it's optional in the sense that many of our local poly program itself already have internship components. And so we actually value those experience and we accounted for. So for poly students, it's not compulsory for them to actually take on industrial attachment or internship. But many of the poly students, after they join NUS, they still want to do internship. So we have basically ways for them to actually to continue to embark for a different internship experience. The other type of internship experience that I should also mention is not working with a company, a normal NMC or normal Singapore companies. It's working with startups. And that can be part of our NUS Overseas College programs. So if you're interested in working with startups, which for most of the students who have done an internship with startup, they will tell you that it's a very amazing experience because you actually can learn the business part of as well as the technical part to really translate your knowledge into something that will have commercial values. So, so those students who are actually thinking about maybe I want to do something, some internship that is different from just working in a company, well-crafted internship program. Think about startups. So that's something that I encourage you to think about it. And again, NUS, because of our NUS Overseas Colleges program or NOC, we have a very strong link with both the overseas startups as well as the Singapore local startup scenes, which is again a very flourish and exuberant environment. So I would highly encourage students who are interested in have a startup experience after they join us, learn more about it and then plan the time to explore to do internships in startups.
Right, so engineering actually have a lot of different kinds of combinations that you can do, different subjects you can combine. So that is called the double major for engineering. So could you share us a bit more about what it is like?
Yeah, so we got a lot of questions on double majors and double degree. The difference between the double majors and double degree is for double degree, at the end of the day, when you graduate, you actually get 2 official degrees. Okay, so the depth and the amount of the work that you need to study for your second degree. So for engineering, we have 2 double degree existing, that the double degree with business as well as econ. So these are the structural double degrees. So when you graduate, you actually get 2 degrees. The one that many of students may not be aware of, we also support self-craft or self-initiated double degrees. So over the years, some student comes in to say, oh, materials, as I mentioned, materials actually cut across many in engineering discipline. Let's say if I'm an EE major, electrical engineering, or mechanical engineering major, but I'm very interested in materials. Can I do a second degree in materials or more physics related materials? We actually allow. So, but then the students need to come up with the second major, second degree, and let the department and the faculty to approve it. So once approved, then the student actually can embark on what we call the self-initiated double degree program. So for those who are interested in, besides studying engineering, another separate disciplines, so that's something that you can consider. So back to the double majors. So double majors, or what we call second majors in NUS context, it still train you to expose to different disciplines, but the depth is not as much as second degree. And so when you graduate from engineering, you still get 1 engineering degree, but then in your transcript, you actually mentioned that you actually get a second major or double majors. And you can go to our website or admission portal to see. We actually have quite a diverse number of second majors or double majors for engineering students to choose from besides business, etc. So please take some time and then try to understand our double degree, double major and double degree. And again, all these programs you can apply during the admission time, or if you think you need more time to think about it, join us first, and then you can actually apply for the double degree and double majors after you join us.
So maybe I can just share a bit as well. So I think the great thing about NUS engineering is that, or NUS in general, is that you actually get a chance to do a lot of electives in NUS. So that means you can take subjects which are totally outside of your expertise, and that also means that you can do some form of specialization in the form of minors as well. So not forgetting minors. So besides majors, NUS also allow minors, and you can even take on multiple minors. So for instance, I'm doing a minor in economics as well as a minor in management itself. So that means that you actually have that kind of breadth of education which you get to really experience in NUS itself. So, and these are all kind of choices which I made only when I was in NUS, after deciding it for a while. And so I think you should actually really come in with an open mind. Don't be too fixated on coming in straight for a double major, because you can actually still do it within NUS itself. So there's that kind of possibility and flexibility which NUS engineering does provide.
Okay, thank you. So we have come to nearly the end of the session, live session. There's another live session later on, so you can, if you have any more questions, you can visit us later. And as a parting word, we can have some words from Nardine.
Okay, thanks. Yes. So just a few things. Of course, I know this is an important time of your life in terms of choosing what you're going to do for the years to come, and it will definitely shape where you head to, right? So the few things that, as a word of advice for people who are choosing, basically making decisions like educational program, is that first, make sure that you line up with what you're interested in. One, okay. Our program in engineering basically gives you a very broad view. Definitely, it's going to be an exciting journey. Definitely, for sure, that come experience it for one thing, and then we'll help you market yourself. So the like what has been said, right? There are multiple minors you can get into, multiple majors you can get into, even double degrees. So these are all programs that actually try to balance your interests and trying to make you marketable when you graduate. So I think if you need more information, please check out our websites. Ask the seniors here, talk to our professors. That's the best way to learn. But I think nothing beats going through it yourself and experiencing it. Okay? All right, so best of luck. And if you have any questions, even if you want to contact me, you can find my contact online, and you can contact me anytime. All right? Thank you.
Okay, so that we have come to the end. You can look for our next stream at 2 p.m. That's for e-scholars, and 2:30 for IDP program, and at 4 p.m. for a general chat session again. All right, thank you.
Like this?
Okay.
Oh.